Imagine standing on a world so bizarre that it rains glass sideways, shredding everything in its path. Picture a planet made entirely of diamond, glittering coldly against the void of space, or, envision orbiting twin suns in a sky that never sets, casting perpetual twilight over alien landscapes. Welcome to the universe's collection of the weirdest planets ever discovered, worlds so strange and unsettling, they defy our wildest imaginations and make science fiction seem dull in comparison. Our journey begins with HD 189733b, a planet of nightmares. Located 63 light-years away, this gas giant is not only blisteringly hot, with temperatures soaring above 1,700 degrees Fahrenheit, but also features terrifying weather conditions. Imagine winds racing at speeds of 5,400 miles per hour. That's 7 times faster than the speed of sound on Earth. Even stranger, the atmosphere is saturated with silicate particles, effectively glass, causing horizontal rains of molten glass. These storms tear across the planet relentlessly, creating an environment so hostile, no known form of life could possibly survive. But if you think glass storms sound terrifying, wait until you meet TRES 2b, the darkest known world in the universe. Orbiting roughly 750 light-years away, this gas giant absorbs more than 99% of the light that reaches it, making it darker than the blackest coal or darkest ink imaginable. Scientists speculate the atmosphere might be filled with vaporized sodium, potassium, or even titanium oxide gases, all absorbing light relentlessly. Imagine descending into this abyss, where shadows lose meaning and darkness envelops you completely, leaving you utterly alone in the void. Traveling deeper into the cosmic oddities, we find 55 Cancri E, an exoplanet orbiting a sun-like star roughly 40 light-years from Earth. What's so special about this planet? Well, scientists theorize it's made largely of diamond. Under immense pressures and temperatures reaching 4,900 degrees Fahrenheit, carbon atoms are compressed into solid diamond, creating a planet that's essentially one giant gemstone. This diamond planet not only challenges our understanding of planetary formation, but also sparks wild speculations about future interstellar mining missions, prompting ethical and economic debates that will captivate humanity for generations. Our cosmic odyssey grows stranger still with WASP-12b, a planet that's literally being eaten alive by its star. Orbiting incredibly close to its parent star, the planet is stretched into an egg-like shape due to immense gravitational forces. Every second it loses nearly 6 billion metric tons of material, streaming off into space in a spectacular cosmic death spiral. Within 10 million years, a blink in cosmic time, this world will vanish entirely, devoured by its own sun, serving as a chilling reminder of the fragile balance between planets and their stars. From destruction, we shift to eeriness. Meet Kepler-16b, famously known as the real-life Tatooine, after the iconic world from Star Wars. This planet orbits 2 suns, creating stunning double sunsets and perpetual twilight. Imagine landscapes bathed in a constant blend of golden and crimson light, shadows doubling, and days without true nightfall. This bizarre celestial arrangement not only fascinates astronomers, but also challenges our understanding of planetary stability and climate dynamics, making us wonder how life, if it exists there, would adapt to such conditions. But hold on, because our next stop takes us to Gliese 436b, an ice planet that's somehow on fire. Confused? So we're astronomers. Despite surface temperatures hot enough to ignite any earthly object, reaching over 800 degrees Fahrenheit, this world is composed largely of ice. However, immense gravity compresses the ice into exotic forms, preventing it from melting despite the intense heat. Instead, the planet's surface literally burns with steam, enveloping it in a thick, steamy atmosphere. This burning ice planet is a paradox in physics, challenging everything we know about states of matter. As if flaming ice wasn't enough, imagine a planet older than its own star, Welcome to PSRB 1600-2026b, affectionately known as Methuselah, estimated to be nearly 13 billion years old, only a billion years younger than the universe itself. This ancient world orbits a pair of dead stars, including a pulsar and a white dwarf. How did a planet survive such cosmic chaos and outlive its stars? Its existence alone stretches our understanding of planetary lifespans and resilience, raising fascinating questions about the ultimate fate of worlds, including our own. Journey even further into the bizarre and you'll find GJ 1214be, a world entirely covered in water, a true ocean planet. Unlike Earth's oceans, however, this planet's waters might be a form of exotic hot ice under immense pressures with temperatures high enough to boil yet kept solid by crushing gravity. Imagine an endless global ocean devoid of land, sky perpetually shrouded in thick mist and vapor. This alien ocean challenges our notion of habitability, pushing scientists to rethink what environments might host extraterrestrial life. Next, prepare for HD 80606be, a planet experiencing the most extreme climate shifts ever recorded. This gas giant swings wildly in its elliptical orbit, plunging extremely close to its star, heating up from frigid temperatures of -370 degrees Fahrenheit to blistering highs over 2,200 degrees Fahrenheit in just 6 hours. So, just imagine seasons changing dramatically within a single day, storms and hurricanes whipped into a frenzy by this brutal temperature swing, creating a turbulent, violent atmosphere unlike anything we've really seen before. Lastly, we visit Kelt 9b, the hottest known planet, with surface temperatures exceeding some stars themselves. At temperatures surpassing 7,800 degrees Fahrenheit, molecules are torn apart, metals vaporize, and the atmosphere is, well, essentially a boiling cauldron of plasma. Orbiting its star every 36 hours, Kelt 9b is so scorching that it's losing its atmosphere at an alarming rate, literally evaporating into space. This planet represents an extreme limit for planetary conditions, pushing astronomers to reconsider the very definition of a planet. From planets of eternal darkness and diamond worlds to planets burning ice and ones ripped apart by their stars, the universe continuously surprises us with bizarre and extreme worlds. These discoveries are not just astronomical curiosities, they are windows into cosmic processes, challenging our theories, inspiring imagination, and reminding us that reality is far stranger than fiction could ever be. Continuing our celestial exploration, let's venture toward HAT P7b, another bizarre giant locked in an eternal, deadly embrace with its star. Located approximately 1,000 light-years away, this gas giant is not only tidally locked, meaning one side perpetually faces its blazing sun, but it's also racked by violent storms made of corundum, the mineral that forms rubies and sapphires. Imagine standing beneath swirling, gemstone-laden clouds raining molten rubies and sapphires at velocities faster than bullets, ripping through the atmosphere in a dazzling but lethal spectacle. The scorching daylight side of HAT P7b blazes at temperatures above 4,500 degrees Fahrenheit, ensuring these precious stones remain in a vicious liquid state, eternally tormenting this alien world with their fiery showers. Next, prepare yourself for a truly uncanny planet, Gliese 581c, a super-Earth lurking 20 light-years away. Initially thought potentially habitable, further investigation revealed a chilling truth. This planet is tidally locked as well, leaving one hemisphere bathed in perpetual scorching sunlight and the other submerged in eternal darkness. The thin strip between these extremes, called the Terminator line, might offer conditions just barely suitable for life. Yet imagine dwelling within that narrow twilight boundary, enduring gale force winds, brutal temperature gradients, and an endless twilight sky. The world's atmosphere is likely thick with choking carbon dioxide, creating a greenhouse effect powerful enough to fry anything on its sunward side, while freezing temperatures consume the dark side. Could any life adapt to exist in such delicate balance, trapped forever in this thin margin between inferno and ice? Venturing deeper still, we encounter PSRJ 1719-1438b, a bizarre celestial oddity orbiting not a typical star, but a pulsar, a rapidly spinning neutron star left over from a supernova explosion. What's even more astounding is that this planet, likely composed of crystalline carbon, might also be largely diamond, similar to 55 Cancri E. But this world isn't just exotic, it's incredibly compact, denser than anything we've imagined, squeezed tightly by the pulsar's intense gravitational grip. Imagine a planet smaller than Jupiter but denser than lead, spinning dizzyingly close to a star that emits deadly radiation beams, bathing the planet in lethal pulses of energy thousands of times per second. It's a world that seems more suited to nightmare than reality. Continuing our bizarre planetary trek, we arrive at Kepler 10b, an exoplanet located roughly 560 light-years away, and one of the smallest yet densest rocky planets ever discovered. With a surface temperature around 2,500 degrees Fahrenheit, Kepler 10b is essentially a scorched ball of molten rock. Imagine oceans of liquid lava covering its entire surface, perpetually glowing red-hot under an oppressive sky devoid of atmosphere. Standing on its volcanic shores, you'd witness explosive eruptions constantly reshaping the fiery landscape. Such violent geological activity makes Earth's volcanoes seem like mere candle flames by comparison, providing astronomers critical insights into planetary formation and geology under extreme conditions. Even stranger than molten lava worlds, consider HD 188753 AB, a planet caught in the gravitational tug-of-war of three suns. Yes, three. This planet resides within a triple-star system, orbiting closely around one star, while two others orbit each other farther away. Picture its skies, a dazzling array of three suns constantly rising and setting, creating strange patterns of day and night that defy all earthly logic. Not only would this cause incredibly complex gravitational interactions, but seasons and weather would fluctuate unpredictably, plunging the planet into chaos. The existence of HD 188753 AB has astronomers rethinking the complexity possible in planetary systems and pondering how life might adapt to such chaotic, unstable worlds. And just when you thought you'd seen it all, we meet Ogle 2005 BLG 390 LB, one of the most distant and coldest exoplanets ever detected. Located approximately 21,500 light-years away near the center of the Milky Way, this icy world orbits a dim, dying red dwarf star. With surface temperatures plunging to minus 364 degrees Fahrenheit, it is permanently encased in ice. Imagine a world eternally frozen, silent, and hauntingly still, where any potential oceans or atmospheres lie buried beneath thick, impenetrable sheets of ice. Yet, beneath this eternal winter, could geothermal activity or other exotic forces sustain liquid water and perhaps even life? It's a tantalizing, eerie possibility that fuels endless speculation. Further adding to our cosmic collection is HD 131399 AB, a planet that, well, defies traditional orbital mechanics. Located roughly 340 light-years away, this gas giant navigates a precarious orbit within a triple-star system. For roughly half of its 550-year-long orbit, all three suns are visible in the sky simultaneously, offering astonishingly bright daylight. Finally, we arrive at WASP-17b, a planet renowned for its bizarre backward orbit. Unlike the orderly clockwise orbits seen in our solar system, this gas giant orbits its star in a retrograde manner, opposite to the direction of its star's rotation. This strange motion is believed to result from a violent collision in its distant past, flipping its trajectory into a bizarre reversal. Imagine watching the sun rise in the west and set in the east, defying every expectation you have about planetary behavior. Each of these worlds, from diamond planets and flaming ice to planets raining rubies and triple-star orbits, provides a powerful testament to the boundless imagination of the universe itself. With every discovery, scientists are forced to reconsider our understanding of planetary science, pushing the boundaries of what we believed possible. The universe's collection of bizarre planets isn't merely a cosmic curiosity, it represents the infinite potential for wonder, discovery, and perhaps even life, lurking in corners of space we have yet to explore. As telescopes grow stronger and missions more ambitious, one thing remains certain. The weirdest planets we know today may soon seem perfectly ordinary compared to the wonders awaiting us in the vast cosmic unknown.